Wanted to give you a little homework help for lesson 6.6. This is page 420, and looks like I've chosen altogether 7 problems. And I picked these first two, 28 and 29, because they're a little different than the examples that I gave you in class. So for that reason, just for watching this and getting them right, I'm going to give you bonus points for just doing these correctly, and hopefully, obviously, if you watch this, then you're going to get them right. So here we go. Here's how this one's, and these two are a little bit different. We still want to think about a way to factor 40 using at least one of these given log expressions. So obviously you're thinking, well, I know that log base 5 of 8 times 5 is 40. That's another way of saying log base 5 of 40. The problem is they didn't give me log base 5 of 8. I know what log base 5 of 5 is, but don't know right off the top of my head what log base 5 of 8 is. So this is where you got to get kind of creative. Using what we do have, log base 5 of 4, is there a way that we can make that into an equivalent expression equal to 8? Well, the reason why I'm counting this as a bonus, they kind of threw you a curveball here. I think they have an understanding that you understand about rational exponents. So let me get off the track here for just a second. We've looked at rational exponents like this. We know that 16 to the 1/2 power is equal to 4. That's another way of saying the square root of 16. Well, the reason why that's the square root of 16 is this bottom number is what we call the index for the radical. So just think of this 2 sliding in here into this little gap, and for square roots it's understood to be 2. We don't write the 2. The top part of this fraction stays with the 16 as an exponent. Okay, so the 16 to the 1/2 in radical form is the square root from the bottom number of 16 to the first from the top number of the fraction, which is 4. Okay, well, let me give you some other rational exponents. Just a quick little study in rational exponents. We'll probably get to this a little bit later in the year. What about something like 9 to the 3/2 power? Well, using that same methodology, the bottom number indicates the root. So this is going to be the square root of 9 to the 3rd power. Okay, so wow, that's a big number. How do we do that? Well, when you get to this point, you can break it up into 2 parts. Think about the square root of 9, which is 3, and then raise 3 to the 3rd power. So now that you've looked at it, it's really not too bad after all. You can do it without a calculator. It's just the square root of 9 cubed, which is 27. So that quick little exercise in what we call rational, or that's another word for fraction exponents, hopefully will make this make a little bit more sense. Okay, because I'm going to find another way of writing 8 using 4 as a base raised to a power. Okay, and the way I'm going to do that is I'm going to do 4 and I'm going to raise it to the 3/2 power. Because once again, in radical form, this is another way of saying the square root. Remember, the bottom number goes as what we call the index, the square root of 4 to the 3rd power. And if we just broke this up into 2 parts, we'd do the square root of 4, which is 2. 2 to the 3rd power is 8. So we found another creative way of expressing 8 using the given number 4 and raising it to a power. Okay, and we'll come back to that in just a second. Alright, so we already know that we're going to use 5. Okay, so now let's apply the product property like we learned in class. Okay, so if we use the product property, we have log base 5 of 4 to the 3/2 plus log base 5 of 5. Remember, the power property says that we can bring this down and use it as a factor. So another way of writing this using the power property is 3/2 log base 5 of 4 plus log base 5 of 5. Alright, so we're given log base 5 of 4, so we need to grab our calculator, and all we have to do is take that decimal that is approximately log base 5 of 4 and multiply it by 3/2, or you could do 3 times this number in your calculator and then divide that by 2. Same thing. Okay, so let's see what we get. 3 times 0.8614 equals, and then divided by 2, that equals 1.2921. Now we know what this is, right? Log base 5 of 5 is just 1, and now we're ready to just add these together to get our final answer. So we get 2.2921. And make that decimal a little plainer. And that is your answer for number 28. So that'll be bonus points for you tomorrow. Okay, this one's similar. Again, I wanted to do this for you because we didn't have anything quite like this in your notes. So let's start off with a way to express 30 like we did in class. We could say log base 5 of 3 times 2 times 5. 3 times 2 is 6, times 5 is 30. Well, I've got log base 5 of 3, no problem. I don't have log base 5 of 2. I do know what log base 5 of 5 is, so the problem's going to be here. But once again, is there a way that I can raise 4 to a power, since I'm given log base 5 of 4, can I raise that to some power to make it equal to? Well, this one's a little bit easier than the previous one. Isn't 4 raised to the 1/2 power equal to 2? Okay, so instead of showing 2, since I'm not given log base 5 of 2, I'm going to show it like this. 3 times 4 to the 1/2 times 5. Still equals 2, but I've used a rational exponent to represent it. Alright, now let's use the product property. Log base 5 of 3. Again, plus, let's go ahead and do the power property while we're at it, like we did up here. Using the power property, this becomes 1/2 log base 5 of 4 plus log base 5 of 5. Okay, so log base 5 of 3 is 0.6826 plus, now log base 5 of 4 is 0.8614, but we're going to be multiplying that by 1/2, which is another way of saying divide by 2. 0.8614 divided by 2 is 0.4307. And of course, log base 5 of 5 is just 1. So now let's add them all up. 0.6826 plus 0.4307 plus 1 gives us 2.1133. And that is our answer for number 29. Alright, I chose some of these log equations to help you out with. Remember in class, the first thing that has to happen is we need to put our logs on the same side of the equation. So that's going to mean subtracting log base 7 10 first. So I'm going to rewrite this other stuff. Log base 7 of 100 minus log base 7 y plus 5 minus log base 7 10 equals 0. And now I'm going to work on putting these 3 separate log expressions together as one single log, and it looks like I'm going to be using the quotient property. So just do them 2 at a time. I think that makes it easier. So putting these first 2 together, I would have log base 7 of 100 over y plus 5. And I'm just going to bring down minus log base 7 10. Okay, now once again, I'm going to be dividing, so put these together, log base 7. Remember, when you divide by 10, it's the same thing as multiplying by 1/10. Remember that? So let me write it out for you. We're essentially doing 100 divided by y plus 5 divided by 10. It's a complex fraction. So dividing by 10 means to multiply by the inverse of 10, which is 1/10. And that's going to give us 100 over 10y plus 50, distributive property, equals 0. Okay, and once you're into single log form like we are, now you're ready to convert into exponential form. So the base of the exponent will be 7, the exponent will be 0, and we're going to let that equal this fraction 100 over 10y plus 50. Okay, well this is just 1, of course. And now I'm going to multiply by this denominator on both sides. I'll show that step to clear this denominator. So in blue, I'm showing multiplying by the denominator on both sides. That will cancel these. And I'm left with 10y plus 50 equals 100. 10y equals 50. So that means y equals 5. Okay. Now you want to double check because that may look like an answer, but when we actually plug it in, it doesn't work. So let's check with a different color. Log base 7 of 100 minus log base 7 of 10, 5 plus 5. Does that equal log base 7 of 10? Well, using the quotient property, we could treat this as log base 7 of 100 divided by 10, which would give us log base 7 of 10. 100 divided by 10 is 10. So that does work. We have a good answer, and so that is your final answer for number 39. Okay, wanted to try number 42. This is also a little different because in class we were solving for specific numbers. In this, we're just really practicing the properties. So it's not much different. We still want to put our log expressions on the same side. And that's going to mean subtracting log base a of x from both sides. Okay, and now just think about what we did before. We have log base a of 6n minus 3 times log base a of x. So we need to put those together. So they have the same base. We can use the quotient property. Log base a of 6n. Now watch this. I better back up so I won't combine moves here. Remember I said in class that before you can combine logs together you need to clear out any space in front of log. You can't have any numbers in front of log, so let's use the power property here. Log base a 6n minus log base a x cubed minus log base a of x equals 0. Okay, that looks better. Alright, so now let's use the quotient property to join these two together. Log base a of 6n over x cubed, and I'm just going to bring this one down. Just going to do them two at a time. Okay, and once again, we're going to divide these. But remember, again, I'll put it over here. It's like saying 6n over x cubed divided by x. And dividing by x is like multiplying by its reciprocal 1 over x. Alright, so that's going to give us 6n over x to the 4th. Okay, and now we change this into exponential form. A to the 0 power equals 6n over x to the 4th. And we're supposed to solve for n. That's the direction. So I'm going to multiply by, this is just 1. A to the 0 is 1. I'll create a little space over here. 1 equals 6n over x to the fourth. And I'm going to multiply by this denominator, both sides. X to the fourth equals 6n. And now it's pretty easy to solve for n. I just divide by 6. And I get x to the fourth over 6 as my answer. So n is x to the fourth over 6. And there's no need to check these. Notice the directions don't say to check. You just have to solve for n. Get n by itself. All right, let's try 43. Also solve for n. Also need to consolidate our logs on one side of the equation. So log base b of 16 plus 6 log base b of n. And I'm going to subtract log base b x minus 2, make that equal to 0. Okay, before these can be joined together into one log, I need to clean up, I need to move these numbers. So power property, log base b of 16 squared, just 2 becomes the exponent for 16. Also the power property, log base b of n to the sixth. Okay, move that 6. No need to use the power property here. And now I'm ready to put logs together. Well, these first two, again, just take them two at a time, going left to right, and these are added, so I can join these together using multiplication. All right, that's the product property. Log base b, and we can go ahead and find out what 16 squared is. 16 squared is 256 n to the sixth. And then I'll just bring down this other part. All right, now we're subtracting, so we can join these together using the quotient property. So we have log base b of 256 n to the sixth over x minus 2. Okay, so once again, very important, when you get to single log equation form, change it to exponential equation form. B is our base, 0 is the exponent, and we're going to let that equal this fraction, 256 n to the sixth over x minus 2. All right, so I'll just pick it up over here. 1, that's b to the 0, equals this. And now I'm solving for n, so once again I'm going to multiply by this denominator on both sides, x minus 2 times 1. And on the right side it just cancels. Alright, and to solve for n I need to divide by 256. And then finally, to solve for n I need to do the sixth root. And you can just do this by raising both sides to the inverse or the reciprocal of 6. So let's raise it to the 1/6 power on both sides. And that ends up actually being your answer. I'll just write the answer again over here. This makes n to the first. So n is this fraction, x minus 2 over 256 raised to the 1/6 power, which is another way of saying the sixth root of that fraction. Okay, that's a 1/6. All right, we got our answer for 43. Let's keep on moving. Now we're back into solving for a specific number. We're solving for b, and b should end up being a number. So once again, we're going to use our properties. The logs are together on one side. They have the same base. That's good. So two logs in the same base that are being subtracted could be placed together as a single log using division. So I'm going to do log base 2 of 15b minus 15 over negative b squared plus 1, and let that equal 1. Okay, so good job. We now can change this into exponential form now that we're in single log form. So the exponential form will be base 2 with an exponent of 1, and we're going to let that equal this fraction, 15b minus 15 over negative b squared plus 1. Okay, clear out this denominator, multiply by it on both sides. I'll show that here. Alright, that's going to cause these to cancel. On the left side, distribute, so 2 times negative b squared plus 2 times 1. Alright, and it looks like we're going to have a quadratic equation. So let's see, I'm going to move these over here. I like for my lead, my quadratic term to be positive, so I'm going to move negative 2b squared over to the right, and this will be subtracting 2. Okay, so let's see what we got. Wonder if this can be factored, or you could use the quadratic formula. Looks like it can be factored, because if you multiply the first and the last terms together, you get negative 34b squared, and there are factors of that add up to 15. That would be positive 17b and negative 2b. Okay, so there is factoring possible. You could use the box method if you like, but this isn't too bad since there's only one possibility for 2b squared. It's got to be 2b and b. And now let's see, to get 15b in the middle, let's see, we're going to do plus 17 and minus 1. Alright, so my solutions are negative 17 halves for this binomial factor and 1 for this one. Okay, so we need to make sure this may cause a problem in causing us to do the square or the log of a negative number. So let's see if that's true. Kind of cut to the chase here. The problem really is right here. Alright, if this had parentheses around the negative b, indicating that negative b, whatever it is, would be squared, then that would eliminate the problem. But what it says is you square b, and then in essence you multiply it by negative 1. Alright, so let's just say, for example, if b is positive 1, let's just test positive 1 here. Okay, so 1 squared is 1, and this makes negative 1, and negative 1 plus 1 is 0, so that's going to be log base 2 of 0. Okay, now let's move over here. If b is 1, 15 minus 15 is 0. Alright, and we're trying to see if what we have here is equal to 1. Well, log base 2 of 0, that means 2 to the what power would equal 0. Well, there is no way to raise 2 to a power and make it equal to 0. Alright, so that's a problem. And here, when we do negative 17 halves and square it, it becomes positive, but then this makes it negative. So that means we're going to be doing the log of a negative number. Negative 17 halves plus 2 halves will be negative 15 halves. So all that work for number 46, we came down to 2 possible answers, but as it turns out, there is no solution. Neither one of these makes the equation true. Okay, and this is my last one. So let's practice these properties. First off, let's move log base 7 4p to the left side to join the other log expressions. Alright, and now let's work on combining these into a single log, just 2 at a time. Quotient property here. and that's going to be 64. I'm going to write it as it looks, 64 divided by 8/3, but remember, dividing by 8/3 is the same thing as multiplying by 3/8. And if you do a little, think of this as over 1, this would be 1, this would be 8, that's just going to be 24. So if it's okay with you, I'm going to erase this, and I'm going to make this become just 24. Log base 7 of 24. Just wanted you to see how I got it. Okay, and I'll just bring these others down. We'll just attack them 2 at a time. Alright, now the next two, going left to right. Remember, just go left to right. Take them 2 at a time. This is going to be the product property, which says 2 separate logs being added can be joined together using multiplication. Alright, and then finally, I've got the quotient property again. 2 different logs being subtracted can be put together using division. And now that I'm in single log form, I'm going to change this into exponential form. 7 to the 0 power is 48 over 4p. 7 to the 0 is just 1. Multiply by 4p on both sides. Divide by 4 on both sides. And my answer, I think, is 12. But we need to check it. Let's see, to save you a little bit of time, I'm just going to go ahead and tell you that it works. There is no danger of the log of a negative number. You should at least do a visual check just to make sure that actually does work in this. It makes it true. Alright, so those are all the examples I chose. 7 of the homework problems. Hopefully that helps you out with the rest. And if you have any questions on these, let me know.